Hi mathematicians, welcome to this video that is going to help you alleviate the confusion that you have, get rid of any misconception you have about what is known as the greatest common factor and the least common multiple. And you've heard these phrases before. You've heard of the GCF for the greatest common factor and the LCM for the least common multiple, but it's often confusing and sometimes you mix up which one is which, but I'm going to give you a very helpful way to distinguish the two today, to tell the difference between the greatest common factor and the least common multiple. To be successful with this, I think you've heard it in the previous videos if you watched my presentation on greatest common factor and least common multiple, you have to understand what is known as prime factorization. So if you're not quite sure about that, pause this video, go back and watch the video on prime factorization, and this will be an effective tool to help you understand how to find the greatest common factor and least common multiple in very efficient ways using prime factorization to help you. Okay, so let's just do a quick review on what the greatest common factor is. The greatest common factor is the largest shared number, common is what they share, that can divide, a factor's number that can divide a number, or you can multiply with that number to get a remainder of 0. So it is the largest shared number that can divide the given numbers, okay? And then the least common multiple is the smallest shared product. A multiple is a product of a given number. So if you want to find the multiples of 2, just count by 2s. 2, 4, 6, 8, 10. The first multiple of 2 is 2, the second multiple of 2 is 4, the third multiple of 2 is 6, so 3 times 2 is 6, fourth multiple of 2 is 8, 4 times 2, and then the fifth multiple of 2 is 10, so 5 times 2. So the multiples are the products you're going to get when you're multiplying that given number by another whole number, okay? So that's the least common multiple. To find the greatest common factor and the least common multiple of given numbers, our first step is to prime factor those given numbers. That is, write 24, 30, and 42 as simply products of given of prime numbers, okay? So write them as products, so something times something, and those numbers that we're writing in those blanks are going to be just prime numbers. So one tool we can use to help us do that is to use factor trees, the prime factorization of 30, 24, and 42, okay? So I'm just gonna do this. Factor trees are tools we can use to break down a number if it's composite and circle the number if it's prime. So 24 is composite, so it breaks down to 3 times 8. 3 is prime, so I circle that. 8 is not. It's made of 2 times 4. 2 is prime. 4 is prime. No, it's not. So I break that down into 2 times 2. And 2 is prime and 2 is prime. So the abbreviated version of writing out 2 times 2 times 2 times 3, I'm only going to copy down my prime numbers, is going to be what factor do I see written? 2. How many times is it written as a factor? Once, twice, 3 times. So this would be written as 2 to the third power, which is short for 2 times 2 times 2, okay? Times 1 factor of 3, or 3 to the first power, okay? 30's prime factorization is, so 30 breaks down to 5 times 6, 5 is prime, 6 is not, so it breaks down to 2 times 3, and I see 1 factor of 2, there aren't any other 2's, times 1 factor of 3, times 1 factor of 5. So that's the prime factorization of 30. And then the prime factorization of 42 is going to be two times 3 times 7. So if a number is not prime, it's composite, we break it down, and we keep on breaking the number down until we get to only prime numbers, okay? So 2 is prime, 3 is prime, and 7 is prime. I only see 1 factor of each, so I can write 2 times 3 times 7. So the first step in finding either the greatest common factor or the least common multiple is always the same. Prime factor the given numbers, okay? Now that I've prime factored out the given numbers, I'm now going to use my special information information to help me find the greatest common factor. So to find the greatest common factor of the given numbers, we're going to use the product of the, now the greatest common factor is the largest shared number that they have in common that they can be divided by. So they have 3 factors of 2 in 24. Are there 3 factors of 2 in 2 to the first? No, there's only 1. Are there 3 factors of 2 in 2 to the first? No, there's only 1. So 2 to the first, 2 to the first, and 2 to the third. Is there one factor of 2 in 2 to the third? Yes. So we're actually going to be taking to find the greatest common factor, we're going to take the lowest power of each different base. So the lowest powers of each different base, okay? So to find the greatest common factor, 24, 30, and 42, we're going to take the lowest power of base 2. So we have 2 to the third, 2 to the first, 2 to the first. What was the lowest power that I said? 2 to the first. So we're going to write just a 2. You could write a 2 to the first here if you want, but we understand that as 2. Now I'm going to multiply that by, now I see a 3. A 3 here, I see a 3 here, and a 3 here. What power of base 3 do I have in this? 3 to the first, 3 to the first, 3 to the first. So what was the lowest power of base 3 that they have in common? 3 to the first. So I'm going to write that, times 3, okay? Now I come over here, there are no more prime factors here. So I see a 5 in 30, but I don't see a 5 in 24. So technically, 24 has 5 to the 0th power, because any number to the 0th power is 1, okay? That means you don't see any factors of 5 written here. 5 to the, I don't see any factors of 5 written, 0th power. And any number to the 0th power is 1. So technically it has a 5 to the 0th power here. It has a 5 to the 1st power here. And it has a 7 to the, it has a 5 to the 0th power here because there isn't a factor of 5 here. So what's the lowest power of base 5, you said? 5 to the 0th power. So I could write what that is, and that's 1, but it's not going to change 2 times 3, okay? If I wanted to, I could. If you want to, totally fine, all right? Next, we're going to find the lowest power of base 7. What's the lowest power of base 7 that they have in 24? There is no base 7, so 7 to the 0th power. Is there a factor of 7 here? No, so they don't have that in common. And they only have 1 factor of 7 here. So what do they have in common? They don't have any factors of 7 in common. So it's going to be 7 to the 0th power, which is 1. If I multiply 2 times 3, it's still going to be 2 times 3. So you can write it if you want, but you don't need to. So that's it. I found the lowest power of each base when I'm finding the greatest common factor, okay? So, and then I just find the product of this. 2 times 3 is 6, and that's it. 6 is the biggest number that can divide 24, 30, and 42. To find the greatest common factor, you're going to find the lowest power of each base. To find the least common multiple now, we're still going to find the prime factorization of each number, but we're going to take the product of the, well, let's figure out what's going on here. To be a multiple of 24, I need 3 2s, and I need a 3, okay? So I see 1 factor of 2 here and 1 factor of 2 here. If I write down 2 to the first over here, am I going to have all the factors of 2 that I need to make up 24? No. I'm going to have to use 2 to the 3rd power, because in this, I'm going to need three factors of 2 and a 3. I have 2 to the 3rd power, 2 to the 1st power, and 2 to the 1st power. What power am I taking of base 2? I'm taking the highest power. So just think of it this way. To find the least common multiple, the lowest common multiple, I'm going to take the highest power of each base. Okay? So you take the highest power of each base. You're going to take the product of the highest powers of each different base. So what's the highest power of base 2 we see? 2 to the 3rd, 2 to the 1st, 2 to the 1st. What's the highest power? 2 to the 3rd. So we write that. What's the highest power of base 3? We see a 3 to the first, 3 to the first, 3 to the first. What's the highest power of base 3 you said? 3 to the first. So we're going to take a 3 to the first, or simply 3. Now, do we have what we need to make up 30? Do we have what we need to make up 30? We have at least a 2. We have at least a 3, but we don't have this 5 right here, okay? Are there any other 5s in any of the factorizations? No. But in order to be a multiple of 30, I need a factor of 5. So I'm going to multiply by 5 to the first, because that's the highest power of base 5 that's here in all of them. And then what's the highest power of base 7? 7 to the first. There's no 7 there. There's no 7 there, so technically it's 7 to the 0. What's the highest power that you said? 7 to the first. So we multiply this by 7, okay? Now we simplify this out, and whatever this product is going to be of the highest powers of the base, different bases, will be our least common multiple. So 2 to the third is short for 2 times 2 times 2. The exponent tells us how many times it's written as a factor. The base tells us what that factor is. So 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So I write 8 here, times 3 to the first is already simplified, 5 times 7. Okay? Now I'm going to use some properties to help me out, because I don't want to do 8 times 3 and then whatever that is times 5 and then whatever that is times 7. I'm going to use the commutative property and change the order of these numbers around, because I'm multiplying. I'm going to do 8 times 5, that's 40. And then I'm going to multiply 3 by 7. So I'm going to multiply 8 times 5, and then multiply 3 times 7, and then multiply whatever those products are to get the final result. So 8 times 5 I know is 40, and 40 times, and then 3 times 7 is 21. So let me do the multiplication. I get 840. And that is the least common multiple. That is the smallest shared product of what I would count by to get to 24. If I counted by 24s, and I counted by 30s, and I counted by 42s, the first time that I would say a number in common when I was counting by those numbers would be 840. So that's the smallest shared product of 24, 30, and 42 when I'm finding the multiples of those numbers. I hope that this helps you to distinguish the difference between finding the greatest common factor and least common multiple. And again, just get your hands ready, because doing a lot of gestures to help you remember things will help your brain to remember it, because the way the brain works is you have to connect new material to what you already know. You know different dance moves, you know different things about opposites, so we're going to do this to help your brain remember it, okay? So to find the greatest, that is the largest, to find the greatest common factor, the biggest number that can divide given numbers, you're going to take the lowest power of each base. To find the least common multiple, you're going to find the smallest shared product that can of all the given numbers, you're going to take the highest power of each different base. To find the least common multiple, take the highest power of each base. To find the greatest common factor, take the lowest power of each different base. One more time. To find the greatest common factor, take the lowest power of each different base, and the products are going to give you the answer. And then to find the least common multiple, you're going to take the lowest power of each different base. Let's do that again. To take the least common multiple, you're going to find the highest power of each different base. Okay? So they're opposites. You want to find greatest? Take the lowest power. You want to find the least common multiple? Take the highest power. Okay? So with that, you now have a way to distinguish between greatest common factor and least common multiple. When you're doing it with your hands, sometimes if you're not visualizing and saying what you're doing, you might mix up yourself, like I mixed up just now. But now you have a way to actually remember it. Greatest common factor, lowest power of each base. Least common multiple, highest power of each base. After you have prime factored out each number. This way of thinking about it helps you to find a way to find both, without having to use different methods of finding the greatest common factor and least common multiple. You can always prime factor out a number and then use the powers of each base to help you find what those numbers are. With that, I hope you enjoyed this video. I wish you all the best on your math journey. Remember, this is just one point on your math journey, and there are many other points to take yourself to. So without further ado, I wish you all the best, and take care, mathematicians.